Now, let us spend some time on another important data structure, hash table. Let us get started. One of the biggest problems with other data structures is their slowness in search function. Time complexity of search operations is order of n on all the linear data structure. The best case for search operation could be order of log n with binary search tree, which is a nonlinear data structure. Search operation is really important over the others, especially in this digital era. We have humongous data all around us. Getting appropriate data from it is really important. This leads to the creation of a new data structure called Hashtable, where the search or lookup operation can be done in order of 1. This data structure is almost ubiquitous. You can find its usage in almost every application we use. Starting from cache systems, databases, compilers, and almost in all the web and mobile applications we use. Hashing is a technique that is used to uniquely identify a specific object from a group of similar objects. Let us see a couple of real-world examples. In universities, each student is assigned a unique roll number that can be used to retrieve information about them. In libraries, each book is assigned a unique number that can be used to determine information about the book. In hashing, large keys of any data type are converted into small keys with integer data type by using a hash functions. The values are then stored in a data structure called hash table. Main idea of hashing is to distribute entries uniformly across an array. Entries or items usually represented as key value pairs. Each element is assigned a hash value, which is obtained from hash function. By using that hash value, we can access the element in order of 1 time. The implementation of hash function is key, as it is the first operation done for every operation involved. The beauty of hash table data structure lies in the ability to convert any given key into a number, also called as hash value. It is the responsibility of each and every item's hash function definition to ensure its uniqueness. Hash function is not a magical function. Sometimes we could end up with 2 keys mapping to same hash value. For example, in the above example, John Smith and Sandra D are mapped to hash value 152. This condition in hash table is called collision. Collision is definitely bad. It should be avoided with proper hash function implementation. Nevertheless, how hash table data structure should handle collision? One of the popular strategy is to have chaining implemented. With chaining strategy, all the key value pairs with same hash value are linked to form a list and its head pointer is referenced in hash value. In this example, John Smith and Sandra D are linked for hash value 152. This seems to solve the problem, but on a day where everything goes bad, usually referred as worst case scenario, we might end up in all the values falling in same hash bucket and forming a linear linked list of items instead of distributing across different buckets. The issue is we lose the order of 1 time complexity for search operations and have order of n. Order of n is very bad and it is mitigated by using BST to implement chaining. Popular implementations in different languages like Java, Python uses BST for chaining, where the time complexity of search is order of log n. Let us do our usual bit of runtime for the supported operations and space analysis. Like in other linear data structures, the space complexity is order of n as it does not require additional space. Coming main part, runtime analysis. All the operations insert, delete and most important one search can be done order or 1 most of the time. However, if the hash function is not able to distribute items properly, that is there are lot of collisions and if all fall into same hash bucket, we will end up in a linked list structure with additional lookup. Hence, the search will be order of n. With standard linked list-based chaining implementation, even insert and delete operations will have complexity order of n. However, there are other variations where the chaining is implemented with binary search tree to ensure all the operation can be done in order of log n.